this out of the way. I don't know if this is going to fit in the screen, but I'll get it in here as best I can. All right. Are you able to see my screen right now?
Yeah.
Okay, excellent. So we're looking at two triangles, and you're supposed to decide if they're congruent or not, and if they are, which one is it? So there's a long list here. For right triangles, you probably remember this from class or from your notes that you can use hypotenuse leg as an option there, but that's the only one. So if we have a right triangle, we'll be kind of going towards that one. For non-right triangles, we're looking for the following. We're looking for side, 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 angle, side, angle, or angle, angle, side. And this is for congruence, meaning they're exactly the same. Then there's also similarity. And similarity, it has two options, angle, 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 or SSA. So that's kind of where we're going at. Unfortunately, these are type of problems I kind of have to give you the answer to propel you forward, because there's not much that I can do to sort of prompt you to answer it for me. This angle, we're going to call this an angle right here, corresponds to this angle right there. Do you see that?
Yeah.
This side, which I just moved up, I moved away from the angle, is congruent to that side there. And then if I go to the other angle, angle, side, angle, I get angle, side, and then angle there. So it may not look it. You may have to rotate it or rotate your paper. You can't rotate your screen. I suppose if you have a phone, you could if you lock your screen. But you have to imagine that this one on the right is rotated, or the one on the left is rotated. So the correct answer there is angle, side, angle.
All right.
All right, so let's move to the next one here. There's a lot that goes into just trying to get the right answer, and then it's just one button push. But there's a number of things that you have to decide here before making that decision. So let me get the next one posted up here. So here, I'm just going to start with this one. We have a side and a side, another side and another side, another side and another side. So this one is clearly side, side, side.
All right.
Not much to say on that one. Did you? It looks like starting here at the third one, you just snipped in the triangle itself, which is fine.
Yeah.
Which is
All the answers are the same.
yeah, figured as much. All right. So at some point here, what happens is the orientation or the order matters. So what I'm going to do here is I'm going to start with the side. So this side is congruent to this side. And then if I go this direction around the triangle, this angle, I have to go the same way. So I'm just going to assume I'm going this way because there's the angle. Do you see that?
Yeah.
Now, if I follow this path, I get another side, which means that if I follow this path on the side here, the side I'm looking for is over here, but it's not there, is it? It's over here. So I'm expecting these two to be over here, but they're not. And since they're not, these are not congruent.
Right.
I'm going to run through that another way because this is really critical to understand. But you can just for the moment, I'm sure, just submit that it's not congruent. This is the exception. This is where you have to start. So let's just start with this this side right here. So this side corresponds to this side. To get to this angle or to get to this side, I have to go around an angle. Do you see that? I have to go around
Yeah.
this angle. Well, that would be like over here going around this way, but that's not the way that I don't have a single. I have a single line here, but there's not a single line here. So the problem is that these things have to be in the right order. The order matters here. If you're not seeing the like you expect, the way we did it first is to have a single line, a single line, then you see an angle, then you see an angle, then you see a double set of lines, then you see a double set of lines over here, but you don't. So that's why this one is, it's still not congruent. That's number three. Um, Move to number four. Hopefully this one is not an exception, because exceptions are hard to learn from. All right, so let's start with the two-sided one over here. So here's a side and here's a side. From this side, I'm going to go this direction, so I see an angle. Same thing here, I'm going to go here, I see an angle. So I'm looking good because I've so far matched a side to an angle, a side to an angle. If I keep going around, I get to another side. If I keep going around here, do I get to another side? Yes. So this is side, angle, side for congruence. Is that okay? Can we move on to the next one?
Yeah, I got it.
Okay. The next one here is a right triangle. I'm going to snip that in. You can see it's a right triangle. It's a right triangle. So while there's a bunch of other ones that work for non-right triangles, the only one you're looking for is hypotenuse and leg. Meaning, is the hypotenuse here the same as this hypotenuse here? And it
Yeah.
is. So we've got that, got that. Do we have a leg? Hypotenuse leg. Yeah, here's a leg and here's a leg. And that's all because they're both right triangles.
Wait, so how do you find the leg? Because I know what the hypotenuse is, but what is the leg?
All right, let's take a look at a triangle that's not shown here. Something like this. Okay, so the hypotenuse is always across from the right angle. These are both legs. Kind of makes sense. You and I, as far as I know, we both have two legs. Um, the legs have a vertex at the right angle. So they both meet here at this right angle. Both legs meet there.
So like it doesn't matter which leg you use as long as
Oh, it does matter. It does matter. But the point is here is you need the hypotenuse. You need the hypotenuse, and then you need one leg or the other. Let me show you one that doesn't work, because I think that's going to help answer this question. So here is, and I've drawn this. I'm not drawing this to scale, but just imagine that this is the case here. So these are the hypotenuses, and they're congruent. Okay, and I tell you that this one is 5 and this one is 8. Is the leg the same in both of them?
no, no,
No. And what if I tell you that this is 7 and this is 6? Are any of the legs the same?
no.
No, but we got the hypotenuse, but we don't have a leg. No legs the same.
All right.
All right. bringing 6 in here shortly. I get my cursor in the right spot. All right. Determine, okay, so same thing again. So like when I look at this, I want you to see what, I want you to try and visualize what I see here. I see an angle, a side, and an angle. And I kind of see the same thing here. I see an angle, a side, and an angle. But let's go through it a little bit more slowly. But that's kind of what I'm saying. It's like big picture. It's like do you see everything that's going on? You know, maybe not, but let's try it again here. So let's start over here. So here's an angle, and that angle corresponds to this angle over here. I'm going to make a path this way. So I'm going to make a path this way. That side corresponds to that side. Check, check. This angle, check. So this one is angle, side, angle. It's okay if I move on to the next one?
Yeah.
All right. Why don't you try the next one on your own and tell me what you think it is? We've done a bunch of these. I think you can do this one on your own, and just check with me before you submit your answer.
Just side, side, side.
Yes. All right, so that's 7. Okay, let's look at 8. 8, I think, is an exception, so we'll look at that. All right. So I'm going to start here in the top left. Here's the angle, so that goes with this there. It looks like I got a path kind of this way. So I'm going to make a path on this one kind of this way. So the next thing I see on this left side here is a side and a side. And on this one, I see a side and a side. Is there an ASS or an SSA property on your list there? What do you see?
It says SSA, like, not congruent.
Yep, these are not congruent, always not congruent. It can appear like it is. It's like, look, there's 2 sides and an angle, but that's not enough.
All right.
So that was 8. Let's move to 9. Let's move to 9 here. See if you can do 9 on your own, please. This is a known one that does work.
Side angle, side.
Agreed. Side angle, side. Ten also works. It's something that is a congruent statement. This one's it's the kind of the one that isn't as obvious, but give it a try here.
Angle, angle, side.
Yes, angle, angle, side. And the order works like this angle goes with this angle, and if I make a path this way, it's angle, angle, side. If I make a path this way, angle, angle, side. So it works out really nicely in this example. Of course, I lost my place. All right. This is 10. Okay, so we're up to 11. All right, so 11 is something slightly different. Let me run through that with you. One of the things that I don't like that I think could be confusing for learning is that they're mixing congruence with non-congruence with similarity, and they're all kind of related a little bit. They're like Venn diagrams that kind of overlap, but not they're not kind of the right things to teach together here. They usually are in different sections of a textbook. Um, this angle is congruent to this angle. This angle is congruent to this angle. So this path I'm making is that way. This path I'm making over here is this way. The third angles, they don't show as congruent, but they're both 90 degrees. So what does that tell you if they're both 90 degrees? They're both
They're both
congruent.
right.
They're both, yeah, they're both right triangles and they're both congruent. But AAA is used for similarity. And I'll give you an example here. Here's a triangle, and here's a triangle. These appear to have the same angles. Here's a triangle, and here's a bigger triangle, and they all have the same angles. So AAA is not enough for congruence, it's enough for similarity. They could be congruent, but there's no guarantee of it.
Okay.
What can happen though is you're so used to like, oh, it's 3 letters, it must be correct, and you end up saying, yeah, it is congruent by AAA, and it's not. All right, why don't you try number 12 here on your own and tell me if you think you can get it here.
Angle, angle, side.
It is angle, angle, side. I agree. How about 13? It is a right triangle. So for right triangles, there's only one possibility. Does this satisfy the hypotenuse being both congruent and the legs being both congruent?
Yeah.
It does. So this one is good. So after this point, you started sending, oh, the number, okay, 13. Okay, I see what's going on here. 13, 14, 15, 16. Okay, we get back to the numbers. This one, 14 didn't have any numbers. But there it is. Okay, or didn't, I'm sorry, I didn't, the picture you sent with 14 did not have the question with it. For 14, tell me what you see.
Angle, angle, angle.
Angle, angle, angle. And those are not congruent, but they are similar. Fifteen is kind of interesting. Let me snip this in here. This is one of the challenges of geometry. Is like you want to as a student to say, well, but it looks the same. It looks the same. This is number 15 here. You have a side and you have an angle and you have another angle. It might look like that, like for example, this long side is the same as this long side, or this angle is the same as this angle, or somewhere else, but you only have 2 pieces of information here. So unless it's a right triangle, you know that this is it. Like you're done. Like this is there's nothing more you can do here. There's not enough information, or it's not congruent. I can't remember exactly what the option was, but basically you don't know enough here to know if they're congruent or not.
Right.
I think that was an option.
Yeah, it says not enough information, not congruent.
Yeah. All right, number 16. Number 16. It helps when I tell you like it's an exception, or it is congruent, or it's similar. On a test, obviously won't be there, but you know enough now to answer this question. Like we've gone through all of the possibilities, I believe. Here you've got an angle with an angle, a side with a side, and I'm making a path here. So this side goes with this side. This is ASS or SSA. Is this congruent?
No.
No. All right. What I really liked is these screenshots. They're a lot easier to work with than taking pictures, so I appreciate you sending them that way. What else can we work on tonight?
Let me check.
Okay, I will stand by.
Oh, it's just more of this.
Okay.
All right, I think I sent it.
Okay. Take a look here. All right. It looks like you sent over a bunch more pictures, starting at 5. Does that sound right?
Yeah.
Okay. I guess we'll just go through these. These require um, a little bit more and like I'm trying to think of the right word. They require you to be, I guess, a little more mathy. I was going to say assertive, but like you can't just look at them and be like, oh, it's angle side angle. You have to like take a step. Hold on just a second, please.
Okay.
Hey, Maddox, I'm back here. So currently, you have an angle and a side, angle and a side. Okay. And if we just went with this, we would be like, oh, that's not enough, right? But we know that if we were to break these triangles apart, you'd have this angle and this side and this side, and then wouldn't these be congruent as well because they share, like they're the same
Oh
sides?
yeah.
But is that enough? Well, it's a side and a side again, and the order is um, well, is there another option here?
No, it's only three.
Yeah, let's go with that one. It's definitely not side 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 because, and then side angle side you would need another angle which you don't have. I'm sorry, you would need another side, but the angle here's okay. I didn't say this. The angle has to be between the sides, so it's like side angle side. They can't be like, it's not like just pick them and throw them together kind of thing. Sorry if that wasn't a good explanation. I will try and do better on this next one. So
Yeah, I don't understand like the angle has to be between the
yeah,
sides
um,
thing.
this isn't your fault. It's that there's this way of learning where, like, I would say, okay, here's an example of a side 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 problem, and here's all the possible side 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 problems. Then I show you a side angle side problem, and I show you, and I give you all of those, and then I say, here's a synthesis of the two, side 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 and side angle side, and then we would keep building on this so that you could do them. What we're doing is what this instructor or this class is doing is they're throwing them all at you, so you have to kind of learn them all together, and that's where the confusion comes in. Having said all that, we're going to try and do this a little bit better here. This is a side, this is a side, this is a side, this is a side. So we're looking pretty good here. Do we know anything about this top side and this bottom side here?
Mm.
No. Like, there's nothing given. Okay. So that one's out. This angle is congruent to this angle. I had to draw it in, but why are they congruent? If you don't know, I'll tell you, but do you remember why that is?
Because they're vertical angles.
Exactly. So in that case, you have a side angle side. You have a side angle side. The angle is between the sides.
Oh, okay, okay. I get
This
it.
angle is between these two sides. This angle down here is between these two sides.
All right.
That seemed to go a little better. All right. Oh, if you don't mind, did you have any, was anything unusual when you went to book tonight or today for your lesson?
I don't. My mom always does
Oh,
it.
your mom does it. Okay. Well, it worked out, so I'm going to guess there was no issues. I made a slight change, and I haven't had anyone um, test it out other than me, so it's always a bit scary when that happens. Okay. So here's a side, here's an angle, here's a side, here's an angle. The path is going this way. The path is going this way. So what do we need to be true about this side right here?
Oh, what?
What needs to be true about this side right here that I'm over highlighting? I'm not. It's
I
not
don't
clear at
know.
all, is it? It's okay. I'm going to break this apart here. Some of geometry, it's like you got to break things apart. So this side is congruent to this side. This angle is congruent to this angle. See, I'm going this way and this one's going this way. What do we really want to be true about this side and this other side?
That they're congruent.
So they are congruent, and the reason is because it's the same side. So this is congruent to this. I have to draw that in. So this symbol right here, this sort of squiggle, Like it's a squiggle. I don't know if you've seen that before. That means that the side is congruent to itself. So here we have it. We have a side angle and a side angle and a side. And again, I'll point out that that angle has to be between the two sides.
Okay, I got that.
Okay. Okay. Um, let's look at the next one here. Um, Determine if the two triangles are congruent. Okay, same thing as always. We've got a side, a side, a side, and another side. What do we know about this third side?
So it's the same.
It's the same, so it's congruent. So it's like saying side and side here.
Right.
All right, so this one is different than the other ones. It's now saying what information is required so that it's congruent by side, angle, side. Like they're telling you, they're like, we want to use this. To use this, what do we need? Well, we have a side and a side. Do you agree with that?
Yeah.
Do you see that? Why are these angles congruent again? You said it once before.
Vertical angles.
So that's not what they're asking about. Like that's you're supposed to know, and then you're supposed to realize, oh, um, to use side angle side, I really need to go like this path goes this way, this other path goes this way. I really need this segment to be congruent to this one down here with the three lines. So which one is that? And this is letter G. Oh, you got it on your side too.
Like GH is congruent to GC.
Yes, looks like it's that one. All right, I'm gonna just ask that you try number 10 on your own, and I'll let you know if I need to step in here and work through it. But I think you can do this one. So give yourself 30 seconds or 60 seconds to try it out, please.
DE is congruent to YX, or XY is congruent to ED.
Yeah. So the order kind of matters, but you got it. Yep, that's right. How about 11?
IG equals MK.
I'm just going to write down the correct answer for 10 before moving to 11. You said go ahead and yes 11 is IG congruent to MK. Yep. Okay. How about number 12?
Be AC equals HF.
This one wants you to use side angle side though. So what you said would be true if it was side angle side, or if it was side side side. Do you see the SAS under 1 point?
What?
Okay, I'm going to snip this one in.
Oh yeah, I see it.
Okay, so they're basically saying like, no, like what you said is true if you were using side side side, but they're saying no, don't use side side side. Use side angle side. So it's this angle's got to be congruent to this angle.
Yeah.
Another thing is that option wasn't there. I don't believe. Well, actually, it was there, which is interesting.
Right, that's all I have. Oh, I have a problem. Like,
Okay, we should have time to get through it here.
all right,
I'll wait for you to send it over.
all right. I don't know if you'll be able to see that. It's like a weird color.
Go ahead and send it over, and we can. I'll work with it
All right, I sent it.
if I need something different. All right. Yeah. So this is it's just white text on black about black background. All right. That didn't work out very well. Let me snip it in here. All right. You are watching a game of poker on ESPN with your friends. I mean, I don't know anybody your age doing that, but okay. You are trying to figure out the value of each colored chip that is being played. Suppose 12 white, 9 red, 8 yellow, blue, and 0 green chips can be exchanged for 2 white, 1 red, 0 yellow, 1 blue, 1 green chip. Also suppose 1 green equals n blue, 1 blue equals n yellow. 1 yellow equals n red, and 1 red equals n white. Is there a question here?
Oh, yeah. I have to put it in. Do I just email that to you too?
Sure. Yeah, or I mean, if it's simple enough, you can just tell me verbally.
All right. It's what is the whole number rate of exchange for these chips?
Okay. What is the whole number rate
Yeah.
for these chips?
I don't know, it says like of exchange for the chips.
Exchange rate.
Like, what is the whole number? What is the whole number rate of the exchange for these chips?
Okay. Um,
And then is only one exchange rate possible?
so I mean, I'm definitely gonna Google this because initially, I mean, here's what I initially see. 12 white. I'm just gonna organize this as 9 red, 8 yellow, 4 blue, and 0 green. I can. There's this magic exchanger. You know, I don't. And then if I do this, if I throw all these in, I get 2 white, 1 red, 0 yellow, 1 blue, and 1 green. And I don't know about you, but I don't understand this because it's like why would I go from 12 to 2? But um, maybe I'm missing something. Like maybe um, they're worth more. I don't know. And then we get this other information. So it says 1 green is equal to n blue. 1 blue is equal to n yellow. 1 yellow is equal to n red. And one red is equal to n white. Okay, this is weird, but all right. So I mean, have you searched? I mean, have you looked to see if this is online?
No.
Okay, let me do that first, and then we'll proceed. It's not online. Okay, so you have 12. I mean, I don't know. Let's just do it with the. I don't know. I don't even know where to begin on this. Um, I found this on Brainly.
Yeah, I saw it too, but no one has an answer to it.
Yeah. So, oh, God. Like one of the things that doesn't make any sense here is that all the ones on the right are bigger. Um, like, or I'm sorry, on the left are bigger. So like 12 white, 2 white, 12 to 2, 9 to 1, 8 to 0, 4 to 1, 0 to, like the green must be huge. The green must be worth something big, I guess. Like like this green must make up for the fact that these are so small. Like do you follow that at least? Like that's
No.
the only one that's different in this
Oh,
list.
they gained.
Yeah, like this one green must make up for the fact that there's 10 less whites, 8 less reds, 8 less yellows, and 3 less blues. Um, so, um, greens go to blues, blues go to yellows. Okay. Um, okay. So let's just for the moment here assume that one green is equal to 3 blue. I don't think that's right, but it has to be at least 3, because that gets you to if you could exchange the green for a blue, you'd have 4 and 4. Do you see how those match?
Yeah.
Okay, but it's not that it's gonna be at least 4 blue because you need an extra blue there. Like if you make that into 0 and you turn that into 5, because it's 4, 1 plus 4 is 5, you're going to take one of those to convert it to yellow. But I mean, sorry, I think I have a path here, but I don't know that we have enough time to do this. But let me let me see if I can create a little spreadsheet here for us to work with. So let me do a new share. Let me share this book with you. So let's see here. So yeah, I mean this is the problem. It's one green. Let's say it's worth and I got to make this up here equals 5 blue, 5 blue. And how many do you have? What's the current status here? So currently you have 1 blue. So this is current. This is amount, and this is color, and then this will be the new. Um, so we actually have 1 green. So we're gonna take that 1 green down to 0. So we're gonna go equals this minus this, um, and then we're gonna go equals this plus this. Okay. So now we have 6 blue. Is that okay?
Yeah.
You kind of follow what I'm doing here. So now one blue equals some number of yellow. So I'm gonna make a number. I'm just gonna choose 6 because I don't know any better. How many yellows did you have? To start with 0 yellow. So now we don't want to take all of them though. We want to take, how many do we want? We want 0, 4. This is green, blue. We want. So we want to take 2 of these. So we want to take this minus this. No. Yep. So we want to take 2 of the blues and we want to multiply it by the number of yellows. So that gives us 12 yellows. But how many do we want? We want 8 yellows.
8.
8. Okay. So let's go to our next conversion. 1 yellow equals how many red? So I'm just going to go 8 red because I don't know any better. And how many do I have to start with? I have 1 red. Red. So I want this minus this. I'm going to take those 4 and I'm going to multiply it by this plus the one that I have there. That means I have 33. And how many do I want? I want
9.
9 red. And then 1 red equals, I'm going to make up a number. I'm just going to go 2 white. And how many whites do I have? I have 2 whites, but I want 2. I want 2 whites. And so this is, I'm gonna cash in all my reds times this number plus that number. So I have 50 whites. All right, so the idea is that you're only changing these numbers over here now, which I feel like I've made an error somewhere, but let's just say I only want one of those. And then I'm going to cash in one of those. Let's go 5. Let's go 7. Seems like it's getting worse. 2. course. Um, yeah, we don't have enough time for this. I sort of can see the path here. Um, I'll send this to you. I mean, maybe that'll help you with something, but we would need um, we would
Sure.
need more time for this. So I apologize for not being able to get to all this tonight, but I'll send over the notes and the screen recording as soon as I can.
All right.
Okay. All right.
I got it.
Thanks, Maddox. I appreciate you scheduling me. Have a happy Thanksgiving.
All right. You too.
Okay.
Bye.
Bye now.